This is Bob Capetta from the College of the Florida Keys, and this lesson is on solving radical equations. So the first equation I have is the square root of x minus 2 equals 5. Let's go ahead and add 2 to both sides. That will give me the square root of x equals 7. Now at this point I want to square both sides. Square the left side, square the right side to get x by itself. However, that requires a warning. If I square both sides, I may be introducing extra roots that aren't really correct. So whenever we do that, it's very important to check our final answer. Well, the square root of x squared is x, 7 squared is 49, so we have a possible answer of 49. But I have to plug that in to see if it actually works, because when you square both sides, as we did here, you must check your answers to make sure all are reasonable. We only have one answer here, which is 49. Plugging in 49 for x, root 49 minus 2, does that equal 5? Does 7 minus 2 equal 5? It sure does. So if that's the case, that is the solution. So we know that 49 is the solution to that equation. Let's look at a different one. Square root of x plus 7 equals 2. We're going to subtract 7 from both sides, which gives me square root of x equals negative 5, which might make you think right away that we have a problem. Square both sides with the warning, whenever you square both sides, you may introduce non-solutions. So here I get x is negative 5 squared is 25. Let's plug 25 in to see what we get, because when you square both sides, you must check your answers. Plugging in 25 is root 25 plus 7 equal 2. Does 5 plus 7 equal 2? It does not. Therefore, there is no solution to this, no solution to that problem. So again, whenever you square both sides, you absolutely must check to make sure the answers that you get work. So go all the way back to the original equation. So here's our next example. X plus 2 equals the square root of 2x plus 7. I want to get rid of the radical, so I'm going to square both sides. But when I square both sides, I add the warning. When I square both sides, I absolutely must check to make sure that my final answer satisfies the original question. So root 2x plus 7 squared is just 2x plus 7, but x plus 2 squared is x plus 2 times x plus 2. So let's use the multiplication box to make that work. X times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. Adding all this stuff together, we get x squared plus 4x plus 4. So that is x plus 2 quantity squared is x squared plus 4x plus 4. Root 2x plus 7 squared is 2x plus 7. So now I need to get all of the x's on one side. Let's subtract 2x from both sides. Let's subtract 7 from both sides. When I do that, x squared plus 4x minus 2x, x squared plus 2x, 4 minus 7 minus 3 equals 0. At this point, I need to solve that quadratic equation, and the tool I want to use is to factor it. So we'll plug x squared plus 2x minus 3 into our factor box. X squared here minus 3 here. I need to work on the outside so the middle two add up to 2x. X squared has to be x times x. Negative 3, 3 times negative 1 times 3. If I organize it this way, positive 3 times x is 3x, negative 1 times x is negative 1x, 3x minus 1x is indeed 2x. So this becomes x plus 3 times x minus 1 equals 0. So knowing that, we're going to set each factor equal to 0. So either x plus 3 is 0 or x minus 1 is 0. Solving for x, add negative 3 to both sides. X is negative 3. Solving for x, x is 1. But we had the warning. I squared both sides. If I square both sides, I've got to plug my answers in to see if they work. So to emphasize, when you square both sides, you must check your answers. So right now, here is my original question, and here are the two candidates for answers. So I'm going to plug in negative 3, see if it works. I'm going to plug in 1 to see if it works. Plugging in negative 3 for x, negative 3 plus 2, does that equal the square root of 2 times negative 3 plus 7? Negative 3 plus 2 is negative 1. 2 times negative 3 is negative 6 plus 7. Does negative 1 equal the square root of 1? Does negative 1 equal 1? It does not. So when I plugged in negative 3, I have a false statement. Therefore, negative 3 is not a solution. My next strategy is to plug 1 in for x. It'll be 1 plus 2. Does that equal the square root of 2 times 1 plus 7? So plugging in 1 for x, does 1 plus 2 equal 2 times 1 plus 7? 1 plus 2 is 3. 2 times 1 plus 7 is 9. Does 3 equal root 9? And it sure does. 3 equals 3. So plugging in 1, the answer worked. Plugging in negative 3, it did not. Therefore, we know 1 is a solution, and it is the only solution. And I like to write my solutions in curly brace form. So the answer is curly brace 1, only one solution to the original equation, x plus 2 equals the square root of 2x plus 7. Next, I have x equals root x plus 5 plus 1. Typically, we want to isolate a square root, get the square root by itself. So I'm going to subtract 1 from both sides. So that'll give me x minus 1 equals the square root of x plus 5. At this point, I want to get rid of the radical, so I'm going to square both sides. But of course, when I do that, remember, that is a warning. If I square both sides, I must check my solutions to make sure they work in the very original equation. So root x plus 5 squared is just x plus 5. X minus 1 squared we will have to multiply. So again, note the warning. X minus 1 squared, x minus 1 times x minus 1. X times x is x squared. X times negative 1, negative 1x. Negative 1 times x, negative 1x. Negative 1 times negative 1, positive 1. So adding all these together, x squared minus 1x plus 1 would be x squared minus 2x plus 1. So that what x minus 1 squared is, root x plus 5 squared is just x plus 5. So my next line will be x squared minus 2x plus 1 equals x plus 5. We need to solve this. So we're going to subtract 1x from both sides, subtract 5 from both sides. So this is what we have. When I subtract 1x from both sides, subtract 5 from both sides. The left will be x squared minus 3x minus 4. The right side, x minus 1x, 5 minus 5 is 0. And now we need to factor that. So x squared minus 3x minus 4 must be factored. X squared in the first slot, minus 4 in the last slot, negative 3x in the corner. X squared is x times x, minus 4. 2 times negative 2, 4 times negative 1, negative 4 times 1, something like that. So again, x times x is x squared. I'm trying negative 4 times positive 1 is negative 4. Negative 4 times x is negative 4x. 1 times x is 1x. Add them together, negative 4x plus 1x is negative 3x. So we have successfully factored this, and we have x minus 4 times x plus 1 equals 0. So therefore, either x minus 4 is 0 or x plus 1 is 0. So therefore, either x is 4 or x is negative 1. But we had our warning. When we squared both sides, we could introduce a solution that is not really correct. So I need to plug both 4 and negative 1 in to see if they satisfy the conditions of the very original problem. So again, to clarify, when you square both sides, you must check your answers. So here's the original question. X equals root x plus 5 plus 1. Here are our two candidates for solutions. X is 4 and x is negative 1. I'm going to plug in 4 first. X is 4 equals root 4 plus 5 plus 1. 4 plus 5 is 9. Does 4 equal root 9 plus 1? Does 4 equal 3 plus 1? It does. Therefore what? Therefore 4 is a solution. Now we're going to plug negative 1 in for x and see if that is a solution too. So if I plug in negative 1 into our original, it'll be negative 1. Does that equal negative 1 plus 5 square rooted plus 1? Negative 1 plus 5 is root 4 plus 1. Root 4 is 2. Does negative 1 equal 2 plus 1? Does negative 1 equal 3? It does not. So when I plugged in negative 1, it is not a solution. 4 was a solution. Negative 1 was not a solution. So I like to write my final answer using curly braces. My final answer is 4 and only 4. Our next question is the square root of 2x minus 5 minus the square root of x minus 3 equals 1. So I have two radicals. That's a problem. We want to isolate one radical, get one radical by itself on one side. So I'm going to go ahead and add root x minus 3 to both sides, so I will get root 2x minus 5 is 1 plus root x minus 3. That will be the question that we're going to try to solve. Now to solve that, we're going to have to square both sides. Square the left side and I get 2x minus 5. Square the right side, 1 plus the square root of x minus 3 squared. That's going to be a little harder to do. But before I do any of that, I'm going to reiterate the warning. If I square both sides, I absolutely must check my final answers to see if they are reasonable. So note the warning. Square the left side, root 2x minus 5, quantity squared just gives me 2x minus 5. And now I have 1 plus root x minus 3 squared. I will do this with my multiplication box. So that'll be 1 plus root x minus 3 times 1 plus root x minus 3. 1 times 1 is 1. 1 times root x minus 3 is root x minus 3. 1 times root x minus 3 is root x minus 3. Root x minus 3 times root x minus 3 is x minus 3. And you can see all of those multipliers. 1 times 1 is 1. 1 times root x minus 3, root x minus 3. 1 times root x minus 3, root x minus 3. Root x minus 3 times root x minus 3 is x minus 3. Add all these up. And what do we get? We get x minus 3 plus 1, which will be x minus 2. Plus root x minus 3 plus another root x minus 3, which will give me x minus 2 plus 2 times the square root of x minus 3. That is 1 plus root x minus 3 squared. And notice if the length and width are the same, the rectangle is a square. So in essence, when we say squared, you can see in a sense this represents theoretically a square. So now I have 2x minus 5 equals x minus 2 plus 2 times the square root of x minus 3. We need to isolate the radical. So I have x minus 2 plus 2 times the square root of x minus 3. I need to get rid of the x. I need to get rid of the negative 2. So I will subtract x from both sides. I will add 2 to both sides. 2x minus 1x will give me 1x. Negative 5 plus 2 will give me negative 3 equals, that goes away, 2 times the square root of x minus 3. At this point, I want to get rid of the radical. So I want to square both sides. But if we square both sides, we need to remember that there's a warning that we have to check our answers because we may be introducing extraneous roots. So square the left side, x minus 3 quantity squared. Square the right side, 2 times root x minus 3 squared. On the right side, 2 times 2 is 4. Root x minus 3 times root x minus 3 is x minus 3. So the right side gives us that. The left side, x minus 3 squared is x minus 3 times x minus 3. I will go ahead and visualize that again with another square. Length and width are the same. X times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And I get x squared minus 6x plus 9. That's what we're going to have on the left side. Then again on the right side, 2 squared is 4. Root x minus 3 is x minus 3. So x squared minus 6x plus 9 equals 4 times x minus 3. And this is what we're trying to solve. Let's distribute that 4. X squared minus 6x plus 9 equals 4x minus 12. Now I need that to equal 0 if I'm going to have any chance of solving it. So what am I going to do? I'm going to subtract 4x from both sides. I'm going to add 12 to both sides. So that's what we had. X squared minus 6x plus 9 equals 4x minus 12. Subtract 4x from both sides. Add 12 to both sides. Now on the right side, 4x minus 4x is 0. Negative 12 plus 12 is 0. The right side is 0. The left side, x squared minus 6x minus 4x, x squared minus 10x, 9 plus 12 plus 21. So the left side will give us x squared minus 10x plus 21 is 0. And then how do we solve that? We go ahead and plug that into our factor puzzle one more time. First term is x squared, last one is 21, middle term is negative 10x. X squared is x times x, 21. Negative 7 times negative 3, I believe, will work. Negative 3 times x is negative 3x. Negative 7 times x is negative 7x. And you can see negative 3x plus negative 7x is negative 10x out here. So we get x minus 3 times x minus 7 equals 0. If that's the case, either x minus 3 is 0 or x minus 7 is 0. If x minus 3 is 0, x is 3. If x minus 7 is 0, x is 7. But we must check the answers because we had a warning. When we square both sides, you may be introducing extra roots that are not correct. So we go back to our original question, what was way back there. Our original question was this: root 2x minus 5 minus root x minus 3 equals 1. It's very important you go all the way back to the beginning. I'm going to plug in 3, I'm going to plug in 7, and I'm going to see whether or not I get true statements. So plugging in 3 first, 2 times 3 minus 5 square rooted, minus 3 minus 3 square rooted, does that equal 1? 2 times 3 is 6, 6 minus 5 is 1, root 1 minus root 0. That's 1 minus 0. Does 1 minus 0 equal 1? Yes, it does. So if that's the case, plugging in 3 gave me a true statement, so I know that 3 is a solution. Now how about 7? Let's plug 7 into the very first equation. So 2 times 7 minus 5 square rooted minus 7 minus 3 square rooted, does that equal 1? Plugging in 7, 2 times 7 is 14 minus 5, that'll be root 9. 7 minus 3, that'll be root 4. Does the square root of 9 minus the square root of 4 equal 1? Does 3 minus 2 equal 1? Does 1 equal 1? Yes, it does. Therefore, 7 is a solution too. So in this case, both 3 and 7 were solutions. So we're going to list our solution set as curly braces 3, 7. And that will conclude this lesson.